everyone. My name is Rebecca Bullers, and I'm currently a Mazar graduate fellow. My thesis project is focusing on acoustic conditioning in common carp, and we just wrapped up our first field season. So this talk will be a nice little recap of what we accomplished this summer and some of our findings. So, as many of you know, common carp are a highly invasive species that are present in water systems throughout Minnesota and the nation. They have become a major driver in biodiversity and ecosystem loss. They like to stir up sediment while feeding, affecting many native species, as well as contributing to poor water quality and stimulating algae blooms. Physical removal strategies of common carp are most common in carp removal. And it has been shown in the previous phase of this project, as well as many other studies, that common carp are very social feeders. They have the ability to locate bait sites very quickly. So exploiting carp feeding aggregations with bait and removal has been proven to be an effective strategy. And acoustic conditioning has the potential to increase the efficacy of this strategy. So acoustic conditioning has been shown in previous studies in common carp. Two papers that were very influential to the development of our experimental design was a Sloan paper from 2013 on acoustic conditioning and common carp. And the image on the top of the screen is taken from that paper. And then a Zion paper from 2012 that focused on an automatic fishing machine. And in both of these studies, it was shown that common carp have the ability to be acoustically conditioned. The Sloan paper showed that both in a lab and an outdoor pool setting, and they also showed that carp have the ability to localize the source of sound. In the Zion paper, they set up an automatic fishing machine in a reservoir, and common carp were not their intended species, but they were shown to quickly become acoustically conditioned to this fishing machine in a field setting. So since it's been shown that they can be acoustically conditioned, it has the potential to be a great aid in physical removal strategies. A current limitation of bait and removal strategies is the number of carp that can be caught at once because they are feeding through different times in the night. So synchronizing feeding aggregations through acoustic conditioning can lead to the removal of more carp at one time. Auditory cues also travel farther than olfactory cues, so there's a potential of attracting more carp from a larger area. It has the potential to reduce the amount of bait and costs associated with labor, and it also has a minimal effect on native wildlife. So if successful, it could provide an effective, cost-efficient management strategy to common carp removal. So the goals of our field season this summer were to demonstrate acoustic conditioning in a free-ranging carp population in a natural setting. And we would do this by having a latency test that would provide evidence for acoustic conditioning, as well as a directionality test that would determine if carp can localize the source of sound in a natural lake. So our field site was Silver Lake, located in Ramsey County, Minnesota. It's approximately 70 acres, and we established two test sites, as you can see in the image. I'll refer to them as Site 1 and Site 2 throughout the duration of the talk. And the sites were set up about 550 meters away from each other. So it was far enough where the acoustic cue would not travel from site to site. We tagged 140 carp at the beginning of the experiment with passive integrator transponder tags, which I'll refer to as a pit tag and pit system. So we're able to detect their presence at our sites. And then prior to the start of our experiment, we actually did a trial run with some bait to make sure that carp were interested in the bait at that lake as well as our sites. So we knew that there would be some carp coming and going from our baiting sites. We also sound mapped each site, so we knew how far our acoustic cue propagated. So we measure the sound in 45-degree increments from the site every 10 meters for 100 meters, basically to determine how far the sound would travel and when it became indistinguishable from background noise in the lake. So after sound mapping, we found out that at site 1, sound actually traveled up to 250 meters, so much further than we were initially anticipating. However, the sound did not reach site 2, so those sites were still kept separate. And at site 2, sound traveled up to 60 meters. So both of our field sites were fairly identical. They each consisted of a sound system that had an underwater speaker, which you can kind of see the little orange buoy. So that's where our underwater speaker was located, and it was connected to an amplifier, an MP3 player on shore. Then we also had our pit systems that consisted of an antenna underneath our automatic feeder, so we could detect the presence of the carp while they were feeding. And then we had our automatic feeder, which is our 5-gallon bucket that's suspended on a metal post. So all of our power supplies were located on shore, and we were able to remotely control the feeder and the sound, making our presence undetected during the feeding period. So here's a little close-up of our automatic feeder. So we used a UW30 automatic feeder, and we used a 400 hertz pure tone as our acoustic cue. It was played at a sound pressure of 122 decibels, and that was measured 1 meter from our speaker. So that just allows us to know like the strength of the sound propagation. 400 hertz is a frequency that was commonly used in many other acoustic conditioning studies. It's in the carp's sensitivity range, and it's also not harmful to other species. So the bottom image is a graph that kind of shows what our nightly sound looked like. We would have a short burst of sound, then we would wait 30 seconds, so it would be a silent period of 30 seconds, and then another short burst of sound. I also have the sound that I can play for you guys. I just want to make sure that it doesn't kind of burst your eardrums if you have headphones on. So I think I might pass on that, but if you're interested, I could play it at the end of the presentation. So as most first field seasons go, we were not able to follow our experimental timeline as originally planned. So like I discussed in our goals, we originally intended to condition our fish to the acoustic cue and then perform a latency test and directionality test. However, we were never able to actually leave the conditioning phase. So we attempted to acoustically condition site 1, so that was our original test site, and site 2 was our original control site. So we were baiting nightly at both sites, but we were only playing the sound at site 1. And we tried to condition the fish for about a month, and we weren't seeing any results. So instead of following our original timeline, we decided to create 3 treatments where we can compare the fish presence at all sites during those 3 treatments to see if the cue had an effect on the fish or not. So our first treatment was sound and bait. So for the first half of that treatment, we played the sound at site 1 while baiting at both sites. And then for the second part of that treatment, we played the sound at site 2 while baiting still at both sites. So both sites were exposed to the sound. And then for our second treatment, it was sound only. So that happened for 5 days, and we did not bait at either site. We only played the sound. And then our third treatment was bait only. So that also occurred for 5 days, and we baited both sites, but we did not play the sound at either site. So this allowed us to compare carp presence throughout the 3 different treatments. So we had a lot of moving parts every night, so I figured I'd just go through the breakdown of what we were actually doing at the field. So every night during our treatments that included baiting, So our sound and bait treatment, as well as our bait only treatment, we would pre-bait the site with a little bit of corn to try and entice the fish into coming to the site a little bit earlier. Carp are known to be most active at night, but sometimes that can be 3, 4 a.m. So we wanted to see if we can push their feeding times a little bit earlier by kind of releasing a small amount of bait at the beginning of every night. The fish tended to show up between 9 and 10 o'clock, and we were able to monitor the fish presence using biomark remote communications. So we were able to obtain close to real-time tag detections. So as soon as a fish was detected, we were able to go to the site and begin our treatment period for that night. So we waited for at least one fish to be present. And typically that was around 10 o'clock. So our treatment period would last from 10 to 11:20. So it was an hour and a half. It consisted of 9 intervals. So we would do that treatment for 9 intervals, 10 minutes apart. So I'll explain that a bit more in the next slide. But the following morning, we would remove the corn from both sites because we kind of wanted to restrict the time that the carp were eating to our nightly feeding period. So we didn't want them at the site all day. We wanted to form a more tight synchronized aggregation. So we would remove the corn in the morning. So here's an example of what our intervals actually looked like. So like I said before, we would have 9 intervals, each 10 minutes apart. So each interval consisted of, for example, for our sound and bait treatment, at 10 o'clock, we would play the sound and release a small amount of bait. And then we would wait 30 seconds and repeat the sound again and release a small amount of bait. And then we would wait 10 minutes and repeat. So for all treatments, the intervals were the same. It was just the actual treatment that varied. So if it was sound only, we would play the sound, wait 30 seconds and play the sound again. If it was bait only, we would bait, wait 30 seconds and bait again. We just wanted to expose the carp as much as possible to the acoustic cue while they were present at the site. So this was one of our methods that we used in just repeating the cue. So diving into some of our results, this graph shows both sites throughout all 3 treatments. So the top graph is site 1 and the bottom graph in blue is site 2. So it shows the daily carp detections. So each panel is an individual date during that treatment, and it's broken down by hours. So you can see carp were, for our sound and bait treatment area, carp were typically there after midnight and then not there so much throughout the day, and then came back usually around 10, 11, but their higher numbers were after the baiting period, after midnight. Something to keep in mind is that the scale for our y-axis is different for site 1 and site 2. There was consistently more fish at site 2 throughout the whole entire summer. So they had peaks of 15 fish there in an hour, whereas site 1 had a peak of 6 fish in 1 hour. So there was consistently more fish at site 2 throughout the whole summer. But this graph shows that the carp were present at the site during the sound and bait treatment. They kind of disappeared during the sound only treatment and then came back during the bait only treatment. So the number of carp were significantly less during the sound only treatment, which shows that there is a positive relationship with the bait, but maybe not the sound. Also, something to mention is we did not do these treatments back to back. We included a almost 5-day window where we waited for the fish to leave each site before starting the new treatment. So there was kind of a silent window between each treatment before reintroducing the new treatment. So this graph kind of zooms in on the nightly intervals. So this is for site 1 during the sound and bait only treatment. and the black lines denote our intervals. So there's 9 intervals. Most of the time, there were not a lot of fish present during the actual intervals. They came later in the night, usually around 2, 3 a.m. And that was pretty consistent for both site 1 and site 2. So this is the same graph, but for site 2, there's more fish at site 2 consistently, but still not as much as the peak feeding aggregations later in the night. So for example, the graph on the left, or the graph on the right, there was a peak of about 4 fish detected during the actual feeding intervals, but later in the night there was a peak of 15 fish. So it kind of varies night to night. Sometimes the fish will stay for all the intervals, sometimes they'll only stay for the first interval and then disappear. So we wanted to further examine the individual fish behaviors instead of looking at it just on an hourly scale. So these 2 graphs show individual tags at both site 1 and site 2. So the graph on the left in blue is site 2. So for example, this is fish number 916. So this graph shows this fish's specific presence and absence throughout the intervals. So again, some fish would stay for the whole duration of the feeding intervals, and then some fish would disappear right after the first interval. So we wanted to see, is the acoustic cue actually scaring away the fish? Is it deterring them and having the opposite effect that we intended? So we wanted to test whether the carp that were already present at the site remained at the site after the first cue was administered. So to do this, we performed a logistic regression model on the relationship between the fish response, so whether or not they were present after the first interval, and then the treatment type. So in this case, whether it was during the sound and bait treatment or the bait only treatment. So these were the results from our logistic regression. So it showed that there was a non-significant bait effect over the sound and bait treatment. So this suggests that the acoustic cue had no effect on carp presence at our study lake. It doesn't seem like they had a positive or negative effect on carp presence. So just to kind of wrap up what I discussed during all of those graphs, it seemed that carp did respond positively to the bait in our study lake. And then the acoustic cue had no effect on carp presence in our study lake. So this was our first season, so it's still only the beginning of our project. So we plan on further examining the individual fish responses on the acoustic cue by performing more statistical analysis. We just wrapped up our field season, so we still have a lot of data to try to work through, but we also would like to go into the lab this upcoming fall and winter and conduct a couple of studies in the lab where we try to conduct a latency test to prove acoustic conditioning once again in a lab setting. But then we also are interested in focusing on the frequency of bait. So acoustic cues can be used as a reinforcing cue, so you might not have to bait carp every single night. So we want to play around with the frequency that we're baiting, but also are we able to reduce the amount of bait if they're attracted to the cue? Maybe we can just release a little bit of bait at a time instead of baiting how we normally would. And both of these would be very applicable in the field. So hopefully we can take the information that we learn in our lab study and apply it to our next field season. We definitely want to select a higher density carp lake and have more tags and more fish detected at both of our sites. But the experiments that we will be doing next season will have to be determined after we conduct our lab studies. We possibly might conduct the experiments that we discussed upon, the latency and directionality test that we were originally planning for this season, but everything will we'll wait until after the lab study before fine-tuning our plan for next season. So I just want to say thank you to Shemek Bezier and Al Mensinger. Shemek's the PI on this project, and Al provided a lot of the expert knowledge on acoustics that we needed to run this experiment. And special thanks to my technicians, as well as the Silver Lake community. Field season would not have been possible without their support. And funding for this project was provided by Minnesota Aquatic Invasive Species Research Center and the Minnesota Environment and Natural Resource Trust Fund. So with that, open it up to questions.
Thank you, Rebecca. That was wonderful. So just a reminder, if you have questions, please drop them in the Q&A section of the window here. You can click on Q&A down at the bottom of the screen, type your question in there, and then I'll help relay those to Rebecca. While you're doing that, I'll kick us off with the first question. And that is, you mentioned this a little bit in your presentation throughout, but could you kind of explain again, kind of the intended use for this sound and bait? Would it be for like managers, or kind of who's the audience that you're trying to develop this tool for?
Sure. Sorry, I'm just trying to share my screen again. Can you see it still or no?
No, it's down now.
Okay, is it back up?
Yep.
Okay, perfect. So the intended use would be for managers who are focusing on carp removal. So we hope that this technology would allow us to control carp populations in maybe 1 to 2 seasons. So getting that desired effect more quickly and readily. So it is something that can be implemented to companies that are doing carp removal and are kind of using bait and removal strategies already. So our main focus, I think, of this project was seeing how acoustic conditioning pairs with bait. So the bait and removal would have to be there. So yeah, sorry, does that answer the question?
That answers the question, yeah. So then that idea is that then the sound will reduce how much bait you need or make it more effective to do that removal, right?
Yes. So sound is like the reinforcing cue. So we could potentially not have to bait every single day. We can just bait one day and then take 1 to 2 days off and then bait again. So we won't need as much money going towards bait or labor. So we don't need someone going to the site every single night and refilling the bait. And our goal, I think I can say for next season, is to make all of this remote. So currently we were going to the lake every single night. So the labor cost alone, we're still paying someone to go to the lake to play the sound and release the bait. So hopefully next year we'll have technology that will allow us to do all of that from home. So instead of paying 2 people to go to the lake every night, we can just, reduce the cost of labor by making things remote. So
that's great. That's great. That's a great clarification. Thank you. Okay, I have a couple more questions here that have come in the Q&A. And the first is, in your studies out in the field, did you do any removal of the carp or just testing the methods for the future?
We did not do any removal. We were just testing to see if this worked or not. So we didn't focus on removal for this project.
Okay. So it was just kind of getting them to aggregate and then,
focusing on the feeding aggregations.
That's great. The next one is, does the type of sound matter? You mentioned that it is a type of sound that's used and has been used in other studies, but does that type of sound matter, and has past research suggested that certain sounds are more apt to get a response from fish? So the 400 hertz frequency has been shown to be one of the more effective sounds when conditioning fish, and that has been shown in probably most of the studies that we looked at, and why we used that tone for our project. It also has has minimal effect on native wildlife, so that makes it ideal instead of potentially using another sound that might harm native species. But we did play around with how we presented the sound. So at the beginning of our project, we were actually playing longer tones. So we were playing the 400 hertz tone, but for
30 seconds. When we didn't see any kind of response to that, we attempted to change it up. Certain studies have been pulsing tones, so they would play the sound for 1 second on, 1 second off, 1 second on, 1 second off. So we also attempted to pulse tones, and we still didn't see any response. So that's something else that we would like to potentially bring into the lab portion of our study, looking at the actual duration of the tones and how it's presented and how that might, be helpful in the field. A lot of the times you may have to change the duration of the tone being played when you're in like a larger area. So just kind of fine tuning the presentation, but I think it's pretty much always 400 Hertz is the frequency that's used.
That's great, thank you. And can you speak a little bit to, in previous presentations, for those that have been kind of following this research and has had kind of ongoing phases, is there any chance that the carp kind of get used to the sound, or kind of what, are you able to speak to why they weren't responding to it? Is it just they're getting used to it, or the frequency hasn't been figured out to be most effective, or what are you suspicious of might be the effect of that? Can you speak to that at this point?
Yeah, I think we have to analyze the data a bit more. But something that could be considered for next season is a higher density carp lake, and just making sure that more fish are tagged. Something that we did struggle with at this lake was how attracted they were to the bait. Usually carp, we were baiting with cracked corn, and usually cracked corn is enough, but we saw kind of a lag in interest in bait, and we had to supplement with some fish pellets as well as some other grains, trying to stimulate their interest in the bait. So I don't know if just the interest wasn't there overall and that affected how we were able to condition them. So maybe having a higher density lake in the future would give us some more clear results.
Thank you. I have another question here, but just a reminder for folks, if you do have questions, please drop those into the Q&A box, and we'll keep reading those as we move forward. We have plenty of time here to answer questions, so if you have any, please put them in there. The next question is, does the density of submerged vegetation affect the distance that the sound travels, or the effectiveness of the sound in the lake?
Yes, the propagation of the sound will change throughout the season due to submerged vegetation and other factors. But we were testing the sound throughout the season. We have a hydrophone that we're able to leave in the lake for large durations of time. So we were able to kind of check on that throughout the summer to make sure that the sound was still propagating.
And then how do you think the sound would work in a river with a moving current? Would the current be an issue for those sound waves in the water?
Yes, sound does propagate in a moving river. I know there have been studies where that has been done. I'm probably not the right person to answer this question. If I know Al Mensinger has a lot of experience with sound, but a lot has to do with the substrate, and certain substrate will propagate sound farther, whether it's gravel or sand, that will affect how the sound propagates in a water body. But it does work in rivers, but there's many different factors to how far the sound will travel.
Great. Thank you. And what about, could you talk a little bit about kind of next steps from what you've learned in the field this season and moving into the lab, what your plans are in the lab? Just kind of recap that a little bit for us and talk about kind of where you see this research heading going forward.
Yeah, so I think first and foremost, we have to figure out how to condition the carp. So that is definitely the main goal of our lab study, whether that's playing around with the cue itself or how it's presented. So we first need to figure out how to replicate that. It has been done in studies in the past, so we know that it's possible, just kind of implementing previous studies. So as soon as we're able to condition them, I think the next step would be to focus on kind of, well, how I said frequency of baiting, but how often the cue needs to be played, how often we need to bait. So I think first and foremost, we actually have to condition them in the lab setting, and then everything else will kind of go from there. So our end goal, hopefully for next field season, is to produce a management strategy that can be very like minimal labor wise and very easy to implement and set up. So that's kind of long-term goals, but conditioning them first will kind of pave the way for everything else.
Right. So bringing them into the lab will help you kind of dial that in so that you can then push it back out into the field is the idea.
Yeah, making sure we can do everything in a controlled setting before adding so many more variables. And it will allow us to kind of focus in on individual fish. It'll be easier to kind of observe all of their behaviors and see what's actually happening on a small scale before introducing it into a larger lake.
So I have one more question on the list here, again, to attendees. If you have any other remaining questions, please drop them in. Otherwise, we'll wrap up after this last question. But that one is, do you anticipate a difference of effectiveness in this for higher, you mentioned in a higher population, carp population lake? Do you anticipate in the future, like this would be an effective method if you have a really large population, or if you do draw down that population, would it still be effective with fewer fish in the lake? Or can you speak to that yet at this point?
I don't know how well I can answer that question, but I do think, I'm not sure if it's necessarily the density of the lake, but more so the interest of the fish in bait that will kind of trigger the response that we want. So higher carp are very social species, and they kind of, you know, have very social feeding groups and aggregations. So if more fish are interested in our bait, and we have the potential to acoustically condition more fish in a higher density lake, I think we might have greater success, but I'm not sure how. I think the interest in bait has to be present in order for this to be successful. So in smaller populations, if that interest is still there, maybe it can be equally as successful. But if the interest in the bait kind of diminishes over time, I think that will have an effect on whether or not they're responding to the cue. But this is all hypothetical because if we can't, we still have to condition them first. Shaq, you want to chime in?
Yeah. Before we answer Grace's question, you know, this is sort of this appears to be the theme with the bait and removal strategy in general, that in high density populations it's very easy to attract large numbers of carp with bait and remove them, and you often end up removing, you know, thousands. In low density populations it's much more tricky to attract carp to bait, and you end up removing hundreds or dozens. But if you look at it from the other perspective, if in really high density populations, removing thousands actually makes less of a difference than removing hundreds in a low density population, because the response of a lake to carp biomass is not linear. So if you're down to removing dozens or hundreds, the lake may actually improve faster versus removing removing thousands from tens of thousands of carp in a lake. So I think we've seen that before, that you know, in a lake with high density of carp, you're able to attract a lot onto the bait and remove quite a few, but that doesn't mean that that will result in more effective management. So we have to keep that in mind.
Great, thanks for that clarification.
I guess I'll just summarize that sort of natural progression. You start with removing, you know, thousands easily, and then you're down to removing the hundreds or dozens in a little bit more tricky way, and acoustic conditioning hopefully will help with that.
Thanks, Shemek. All right, so our last question here is, do you see this being used in a box net type removal, or could this also be useful for under ice seining?
I think it could be, as long as there is bait involved, it has the potential to be used for both. I don't really know how, if the ice, how that would affect the propagation of the sound. But I think as long as there is a factor of attracting the carp to a baited site, it might just be more difficult to. Usually the sound is like a 1-time, or I guess a 9-time cue. But I guess our main goal would be to play the sound once and have all the carp come and then kind of remove them immediately. So adding the implement of staining, maybe you wouldn't be able to capture like the whole feeding aggregation, but I don't know enough about under ice staining to maybe speak to this question.
Well, I think that those are a little bit apples and oranges. So as far as we know, the carp don't feed that much under the ice when it gets too cold. So bait related strategies would probably not work very well under the ice. But that doesn't mean that acoustics couldn't be used. But I think that others have been experimenting with using sound to, say, move around those carp aggregations under the ice to position them in a spot that might be better for removal with a seine net. But that's a little bit different application than what we are trying to do. We're trying to use acoustics to essentially let them know that dinner is here in the middle of the summer when they're actively feeding.
Great, thank you. All right, I think we will wrap up there. We're just a few minutes ahead of schedule. Thank you, Rebecca, for your presentation. If you have any other questions that pop up throughout the day for Rebecca, you can, I don't know if you had contact information up on your slide, if you want to go back to that. Otherwise, you can email the general macerc@umn.edu and we can direct those questions to Rebecca and Chemik as well after the showcase.
Also, I will be at the poster session later today, so if anyone has any other questions, you can pop in there.
Great, thank you.